section 4.6, we're now finally going to solve exponential and logarithmic equations. So now that we know what each of those are, we know how they behave, we know what their graphs look like, and we know their properties, we're going to actually use what we've learned to solve some equations of that form. We're going to start off with exponential equations. An exponential equation is any equation with a variable in one of its exponents. So for example, 3 to the x equals 5, 6 to the x minus 3 equals 2 to the x, or you could have base e to the 2x equals 7. And then a really weird one, this final example, 3 to the 2x plus 1 minus 10 times 3 to the x plus 3 equals 0. So any equation that has a variable in the exponent is an exponential equation. Inversely, a logarithmic equation is any equation with logarithmic expressions that also contains a variable. So some examples, log of 2x equals 25, log of x equals log of 1 over x plus 4. So not every term has to contain a logarithm. Sometimes they do, sometimes they don't. Natural log of x minus the natural log of x minus 12 equals 24. All of those are examples of logarithmic equations, and hopefully by the end of this lesson, you'll be able to solve all of those. In order to solve exponential equations, we need to look at some properties of exponents. We know that it's true that if b to the x equals b to the y, then x must equal y. In other words, equal quantities with like bases have to have equal exponents. So here's the thing. If an exponential equation can be rewritten so that the two bases are the same, you should attempt to solve it that way first. So if you can get like bases, then you can pretend the bases aren't there and just set the exponents equal. So that's a quick and easy way that you can solve exponential equations when their bases can be made into the same thing. So for example, let's take a look at 4 to the x plus 3 equals 8 to the 2x power. Notice that your variables are in the exponents on both sides. And then think about the bases. On the left side, the base is 4, but on the right side, the base is 8. Can we rewrite those bases so that they have the same base? In other words, can 4 and 8 be rewritten as the power of the same thing? They can both be rewritten as powers of what? 2, yeah. So you have to find something they can both be rewritten of, and it has to be not a multiple of it, but something that they are a power of. We know that 2 squared is 4 and 2 cubed is 8. So you're going to substitute in the place of the 4, 2 squared. And you're going to substitute in the place of the 8, 2 to the 3rd. So you're going to rewrite them as like bases. Now here's the part where a lot of people kind of go wrong. You have to get rid of those parentheses, and when you do, you have to distribute. So distribute your exponents, and we now have 2 to the 2x plus 6 equals 2 to the 6x. Did everybody follow what we did there? Because 4 and 8 can both be rewritten with base 2. 2 squared is 4, 2 to the 3rd is 8. We did that, we distributed our exponents, and now we know that it must be true that which two things are equal? 2x plus 6 has to equal 6x. We know that's true once the bases are the same. We know the exponents are equal. Then you just solve it very quickly. You have 6 equals 4x. Divide by 4. So it looks like x must equal 3 halves. How could I check it? Yeah, I could store 3 halves for x, right, and substitute it back into both sides of the original equation and make sure it's true. So I want everybody to do that right now. We'll pause for a second, let you store 3 halves, and make sure that the original is true. So when we plug back into the left side, 4 to the 3 halves plus 3, we got 512 equals 8 to the 2 times 3/2, which is the same as 8 to the 3. And that also equaled 512, which means we got the answer right. You should always check your answers for extraneous solutions, just to be sure, and to make sure you didn't make any careless mistakes. Let's take a look at this example. It's a little more complicated. It says 2 to the x squared plus 2x equals 1/2. 2 to the x squared plus 2x equals 1/2. Is it an exponential or logarithmic equation? Exponential. We know because the variable's in the exponent. So one way to solve exponential equations, if possible, is to get the bases the same. The base of the left is 2. What's the base of the right now? What's the base on the right? 1/2. Yeah, there's really, the only exponent on the right is a 1, right? Right? Okay. So 2 and 1/2, can they be rewritten as the same thing?
Yes.
They can both be rewritten as powers of 2, right? So if we keep the left side the same, 2 to the x squared plus 2x, how can I rewrite 1/2 as a power of 2? That can be rewritten as 2 to the negative 1 power. Good. Remember that you can always turn a fraction into an exponent by simply taking to the negative power. So 1/2 to the negative 1 power would be 2. So 2 to the negative 1 is 1/2. So notice we haven't changed anybody's value. We have just substituted an equal quantity. 1/2 and 2 to the negative 1 are equal to the same thing. Once you have that, the same bases, you can just pretty much pretend the bases aren't there and say that the exponents must be equal. So now we have x squared plus 2x equals negative 1. So what started as an exponential equation has dropped into a quadratic equation. And we can solve I know you're sad about it, aren't you? We can solve quadratic equations a couple of ways. We can get them equal to 0, we can factor, we can do quadratic formula, or completing the square, or in rare cases, the square root property. Let's just try to factor it. Usually that's easier if it'll factor. So let's get it equal to 0. Does that factor?
Yes.
Yes, into what?
X plus 1 squared.
X plus 1, X plus 1. And so we end up getting the same answer twice. X equals, that's called a double root, you guys. X equals negative 1. We should probably check it. So if we store negative 1 for X, go to your calculator, negative 1, stow X, hit enter, type in the left side, 2 to the x squared plus 2x. So type that in and tell me what that equals. 0.5. So when we type that in, that equals 0.5, which is the same as 1/2. So sure enough, x equals negative 1 is our answer. Turned out to be a double root. We only got one answer after all. So, because the bases here in example 3 are already the same, we can just drop the bases and we have 6x squared is equal to negative x plus 1. Right? So we get it equal to 0 because that's a quadratic. 6x squared plus x minus 1 equals 0. And we'll see if that factors. And I think some of you guys do bottoms up, right? But I usually just do trial and error. So let's try that. 2x and 3x will make 6x squared. And the only thing I can multiply to get negative 1 is a positive 1 and a negative 1. So we just have to make sure we get the positive in the right spot. And I think if we check that out, that works. 2x plus 1 and 3x minus 1. That foils back out properly?
Yes.
Okay, so the first one, this guy, x equals what? Negative 1/2. But this guy, x equals positive 1/3. And then has anyone checked those yet?
They both
Yeah,
work.
they both work. Okay, you should check them and make sure they both work. And it turns out they do work. You can check them in your calculator by storing them. Any questions about exponential equations when the bases can be made equal to each other? No?